Hi, this is Aaron Holmberg at Corvallis Middle School in Corvallis, Montana. And I'm teaching here about how to use arrays to learn about the distributive property of multiplication. The distributive property is a really biggie in math, and so I can't really go into all about why we are teaching students to use arrays to think about that, other than as a mathematical property. It's not just true of multiplication, it's true of the other operations as well. And students, by learning how the distributive property works in an array, they have a skill that they'll use throughout the rest of their math career. So it's really important that we're investing it at this age. Another simple way I could maybe show it, though, is that the distributive property is a way of mentally also, with multiplication, being able to solve a math problem in your head. So let's say I have 1,213 times 4. We want students to be able to think this through in their head, and the distributive property allows students to take a number and pull it apart and calculate operations and then assemble it back together. And that's a lot of what the distributive property is about, is saying you can take apart or decompose numbers and perform operations and then reassemble them, and you'll end up with the same result as if you just used a calculation from the beginning. So while an adult might say, well, I know how to use this algorithm and that's good enough, that's true, but we also want students to be able to think like this. In this number, for example, you know that 4 times 1,000 is 4,000. 4 times 200 is 800. 4 times 10 is 40, and 4 times 3 is 12. And you could perform this in your head. None of that math was really that difficult, and you weren't carrying anything. You might be able to imagine or remember these numbers, and then simply add them up as they go to your answer. So that's the distributive property at work, sort of as a mental process. And yeah, it's another way of doing it, and certainly you could use the traditional algorithm, but we want to teach students to be able to think like this in their heads too. So the distributive property then with arrays is what we're working on right now in class. And I just grabbed the back of a math sheet we're working on here. And so you've got this array here. And of course, an array is an arrangement of objects. So you have rows here, and you could count I have 3 rows of whatever number, or I have columns, and I have whatever number of columns of 3. And both of those would be just multiplication equations running different directions, kind of vertically or horizontally. So if I was trying to use the distributive property to find the area of this, what I've been teaching students to do is first just to label the dimensions. So the dimensions are the length of a side. This side's 3. The other side is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I've been teaching them to separate the side that's long, separate it into its tens and ones, or tens and units. And so if this was 16, let me see, I'll just back up 6 here. That means that right here, I could break this side, and although it's 16 as a total length down here, so it's 3 times 16 is really my math problem, 3 times 16, I'm also thinking about it being 3 times 10 plus 3 times 6. These two things are added. And what the distributive property then, if you start to write it out just in math notation, just in numbers notation, you're looking at 3 times 10, which is this space in the array right here, and that is being added onto this other array, this other area over here, that is 3 times 6. And when you add those two things together, they equal 3 times 16. Now, one of the things that students really felt like helped them in class was when I did this. I said, okay, the 3 times 10 part of this array is going to be yellow. And over here is where I find those same 2 dimensions, that factor pair, if you will, or the dimensions of the side. And the other side is the 3 by 6 side. And so there's the 3 by 6. And when I combine them, they're the 3 by 16. And so I could just kind of give it an outline. The whole thing is 3 times 16. And that's this answer at this side. Okay? So when I combine this then, 3 times 10 is 30. So 3 times 10 is 30. And I've been teaching them just to work downward, to get in the habit of having a solution line and move under it and move under it and move under it, because that's a pretty good way to work as you go forward in math. And you're going to add to this 3 times 6, which is 18. And that's still equal to 3 by 16. And I'm keeping this little fact over there because we want to prove that this is how they unite. 30 and 18 you'd add in your head and come up with 48, and 48 is equal to 3 by 16. Okay? Maybe that seems like a lot to learn, but what's important is we're teaching them how to pull these numbers apart and perform an action and then reassemble them. And that's really important to all their later math thinking. And so while it may seem kind of convoluted,